Let's do our last example of potential energy. And on this one, we're going to have two springs. So let's go ahead and draw this one out. All right, so we got a surface up here, and we're going to have a spring. And then there is a rod right here. And down here at the bottom, we've got another spring. Okay, and we're going to have a slider on here. Right, you know, we always have a slider. So this slider is going to be 6 inches tall. All right, and this length of this spring is 10 inches. So that's the unstretched length. The length of this rod is going to be 20 inches. And then the length of this spring up here is also 10 inches. All right, so these are the unstretched lengths. Now our spring constants for this one up here, let's call this spring B. This one is going to be 120 pounds per foot. This one at the bottom, let's call it KA, that is going to be 576 pounds per foot. All right. So that is the scenario. Okay, so now let's see what's going to happen in this problem with this slider. So the mass, which is the slider, is going to be released from rest, so that's important, in a position where the lower spring is compressed 5 inches. All right, so we're going to push this slider down until it compresses the spring 5 inches, and then we're going to let it go. And then this slider is going to slide back up to the top and hit this spring. So what we want to do is we want to find the max compression of the upper spring once this slider hits it. Okay? So that's the scenario. So let's draw an initial picture of this slider pushing down right here. So this will be our initial. All right, so here's the bottom here. And now we've got that. Okay, so now this length right here is 5 inches. And remember, this slider here is still 6 inches. And then we still have, whoops, our spring up here at the top. And then we've got this rod. All right, so this length is still 10 inches. And we've got our rod right here. Okay, so that's what we've got initially. Now this length from the bottom of the slider up to the top here is 25 inches. All right, so we started at 20, but remember we compressed this spring down by 5. So now this, from the top of this bottom spring to the bottom of the top spring, is 25 inches. So that is our initial case. All right. Now the final picture, let's see what that looks like. So finally we're going to have this spring at the top, it's going to be compressed. Okay. So this length here is going to be the 10 minus XB. So XB is going to be the amount it was compressed. And then we've got the slider. Then you've got your spring at the bottom, which is 10 again. And then you've got your rod. Okay? So that's what we have in the final scenario. Okay, so I want to find this XB. This is what I'm looking for. I want to know how much that spring was compressed once that slider hits it. Now again, this is a problem you want to use your potential energy to solve. All right, so this equation. We know this because we've got springs, we've got a change in height, we got gravity, so this is a good choice. Okay, so to start off with, U, do we need to do anything with that? No, because we don't have an external force, so that goes away. And then delta T, let's go ahead and look at delta T. That's going to be 1/2, and then we're going to have the mass. What's the mass going to be? the mass is going to be 14 over 32.2. All right. Let's see. You might be wondering where that came from. I forgot to write it down here, but the weight of this is 14 pounds. All right. So this will give us our mass, and then we need the final velocity squared minus the initial velocity squared. So we'll have VB squared minus VA squared. Now let's think about that. So VB, B being up here at the top, if I'm getting the max compression, what would my velocity be at max compression? Should be 0, right? Because we're going to get the max compression when the slider goes up as far as it can, and then it stops, and then eventually it falls back down. Okay, so we want to go until this velocity or speed is 0. And then what is our initial? Well, that was given, right? It said it was initially at rest, so that's 0 there. So that was easy enough. Everything's 0. Now let's do the gravity portion. So delta VG. Remember, this is mg times delta H. mg is 14. So we got 14. And now we need to get our lengths. All right, so what we need to do first, let's convert all of these inches over to feet. Now let's write those down. So 25 inches is 2.083 feet. 10 inches is 0.833 feet. And 6 inches, that'll be 0.5 feet. 5 inches is 0.4167 feet. All right, so now we have everything in feet. Perfect. Now we're ready to find our final height. All right, so pick your reference line. So you got to figure out where you're going to measure from. I am going to measure from the top of this spring right here. All right, that's going to be my reference line. All right, so if this is my reference line here, the bottom of this slider, then when I go to my final position up here, we got to think about what that'll be. So that's going to be the 25 inches because we're measuring from the bottom of the slider. So it's going to go up that 25 inches. Whoops, that's not right, 25. 2.083. And then what we need to do is we need to subtract this 0.5. All right, because the slider is 6 inches itself. So let's go ahead and subtract the 0.5. All right, and then once we get that, that gives us this distance here, right? And now I need to know how far up we went, right? Because I traveled this max compression length, right? So I need to have plus xb. Does that make sense? All right, so now we've got that. And then that is going to be your final one. My initial is going to be, let's put parentheses on here again. So my initial location, here's my reference line. Well, this is going to be 0. All right, if I measure to the bottom of that slider. So that's what I'll get for that. Now if you simplify all that, it's going to be a function of xb. So delta Vg is 22.17 plus 14xb. Remember, x here is the compression amount, not the length of the spring. Okay, so now we got that. And what do we need to do next? We got this one, we got this one, now we got this. Now this takes care of our springs. Now you've got 2 springs, so you're going to do one of those equations for the potential energy for each one of these springs. All right, so let's do this top one first. So we're going to have 1/2 times k, which is 120, and then you want the stretch or compression in the final position. So here, our stretch or compression, what's that going to be? It's going to be XB, right? Because XB was the amount we were compressed. So of XB squared, and then initially, how much was this top spring compressed? It wasn't compressed at all, right? So this is going to be 0. We've got that, and then on top of that, we need to look at this second term. All right, so now let's go to the bottom spring. So we're going to have 1/2 times 576. And now we need to look at the final compression in the bottom spring. Well, is this compressed right here? Nope. So that's 0. And then we subtract the initial compression. So remember it said the slider initially had compressed this spring 5 inches. So here we're going to put 5 squared. Actually, we don't want 5. I keep writing it in inches here. It's going to be 0.4167 squared. All right. So now you got that. So you have to do this for each spring you have. Okay, so if you had 4 springs, you need 4 of these equations. All right. Now with that, you can go ahead and simplify that, and you should end up getting 60xb squared minus 50.01. Okay, so now we got that. We got everything we need now. So let's go ahead and put it all together. We're going to have 0 equals 0, because of delta t, plus the 22.17 plus 14xb, and then plus 60xb squared minus 50.01. All right, so now that we got that, you can simplify that a little bit. You get 60xb squared plus 14xb minus 27.84. Set it equal to 0. Now you just do your quadratic equation. You'll get the value for xb, which is going to be 0.574 feet. If you want it in inches, that's 6.89 inches. All right. So basically, once we let this slider go, it's going to slide up, it's going to hit that spring, and it's going to keep moving 6.89 inches until it stops. And then eventually it falls back down. Okay? But that's how you go about doing a problem like that. So it's just important to keep your reference line in mind and just know what you're measuring from. And then if you have multiple springs, you got to do potential energy for each separate spring. All right. That's the end of that section. And in the next video, we will start a new chapter. We'll get into impulse and momentum. See y'all then.